These examples go with lesson 1.6, transformations of graphs. Example 1. Use translations to graph the function g of x is equal to the square root of x minus 2. And then we'll use translations to graph the function h of x is equal to the square root of x plus 3. All right, the parent function is the square root function. And I know that the parent function contains the following ordered pairs. When x is equal to 0, the square root of 0 is 0. When x is equal to 1, the square root of 1 is 1. And when x is equal to 4, the square root of 4 is 2. So the parent function has a point here, a point here, and a point here. And it looks kind of like half of a parabola laying on its side there. Okay. Now, if we're going to do the transformation, or the translation, we need to take the parent graph right here, and then this part tells me we want to move it down to. So I'm going to take each one of these points, and I'm going to move it down to. This one's going to move down here. This one's going to move 1, 2, down to here. And this one's going to move down 1, 2, to here. So the transformed graph g of x is now my pink graph. All right, let's look over on the other one. We're looking at the h of x graph. Again, the parent graph is the f of the square root function. So I know I'm going to have a point at 0, 0, at 1, 1, and at positive 4, positive 2. So the parent function is going to go kind of like this right here. Now what we're supposed to do is we're supposed to take the parent function square root of x and move everything up 3. This point will move up 1, 2, 3 to here. This point will move up 1, 2, 3 to here. And this point will move up 1, 2, 3 to here. So my translated h function graph will be the green one right there. Example 2. Graph the function defined by g of x is equal to the absolute value of 2. All right, the parent function is the absolute value graph, the absolute value of x. Now I know that the absolute value graph contains the following points. When I put 0 in for x, the absolute value of x is 0. When I put negative 1 in for x, the absolute value of negative 1 is positive 1. And when I put in positive 1 for x, the absolute value of positive 1 is positive 1. So my parent function is going to have a point here at 0, 0, a point here at 1, 1, and a point here at negative 1, positive 1. And our picture is going to do something like this right here. Now to translate this thing, since this 2 is actually grouped inside the absolute values with the x, this is going to be a left-right translation. And this one is actually going to move everything to the left 2 times. So we're going to take each one of these points and we're going to move it to the left twice. So this point's going to go to the left here. This point's going to go to the left once, twice here. And this point's going to go to the left once, twice to here. And our new graph, our translated graph, is going to look like that one right there. Use translations to graph a function defined by q of x is equal to the square root of x plus 2 minus 5. Our parent function is going to be the square root of x function. And we just talked about how the points that we know for a fact lie on the parent function are 0, 0, 1, 1, and 4, 2. So let's graph those. 0, 0, 1, 1, and 4, 2. The parent function is going to do something like that right there. Now this function actually has two translations on it. This 2 right here being grouped with the s is going to move everything to the left 2. And then this 5 is going to move everything down. So what I'm going to do is I'm going to take each one of these points and I'm going to move them left 2 and then down 5. All right, this point's going to go left 2 and down 5 to right here. And this point's going to go left 2 and down 5 to right here. And then this point's going to go left 2 and down 5 to right here. And so my translated graph is going to be right here, the orange one. Example 3, we're going to graph the functions. Part A, g of x is equal to 3x squared. Our parent function is f of x is equal to x squared. And this 3 is actually going to provide a vertical stretch on our graph. All right. On the parent function, if I put 0 in for x, 0 squared is 0. If I put 1 in for x, 1 squared is 1. And if I put negative 1 in for x, negative 1 squared is also 1. And this one is going to look a little bit like the V-graph, but it's not going to be quite as harsh and come to a point. This one is actually a parabola, so we want to be sure and have some curvature to it. Okay, now the 3 is actually a vertical stretch, and what that's going to do is it's going to cause my graph to stretch or to grow taller quicker. Okay, so I'm going to add another column in here for the 3 times x squared, and I'm going to multiply 3 times my column right here. So 3 times 0 is 0, 3 times 1 is 3, and 3 times 1 is 3. And I'm going to graph the points 0, 0, positive 1, positive 3, and negative 1, positive 3. That's my new function. 0, 0, we already have that. Positive 1, positive 3 is going to go right here. And negative 1, positive 3 is going to go right here. So my new graph is going to be kind of skinny and fit right inside the purple one. Just like that. It probably should be a little more curvy down here, but you kind of get the idea of what it's going to look like. On the other side, we have the same parent function. The function h of x is equal to 1/3 times x squared. I'm going to use the same points that I had before to draw my parent function. So that's going to be 0, 0, positive 1, positive 1, negative 1, positive 1. And we're going to get something that looks kind of like this right here. And now let's see what happens when we multiply by the 1/3. Now this is going to be a vertical shrink. And what I'm going to do is I'm just going to, I'll go ahead and make a new chart here. We got x squared, and then we'll do 1/3 times x squared. So we know we got 0, 0, 1, 1, negative 1, 1. All right, 1/3 times 0 is 0. 1/3 times 1 is 1/3. And 1/3 times this one is 1/3. My new function will contain the points 0, 0, positive 1, 1/3, negative 1, 1/3. 0, 0 is going to be right here. Positive 1, 1/3 is going to be a little bit here. And then negative 1, positive 1/3 is going to be right in this area here. So my new graph is going to do something like this. It's going to be wider than my original parent function. And that's because the fraction right here, the proper fraction, has actually caused the parabola to open slower. And we have our vertical shrink. Example 4, the graph of f of x is shown. We're going to graph y is equal to f of 2x. Now this 2 actually represents a horizontal shrink. Okay? Horizontal shrink. And it's a horizontal shrink of 1/2. It's 1 divided by the 2 right here. So what we're going to end up doing is multiplying our x coordinates by 1/2. Okay, let's take a look at excuse me, at our coordinates that we have. The ones that they gave us, okay? All right, for this point right here, see, 1, 2, 3, we're at -3, +3. So -3, +3. This point right here, we're at -2, -3. And this point right here is at 0 and +1. All right? Now, what I'm going to do is multiply 1/2 times my x coordinates here. So -3 times 1/2, this is going to be -3/2, or -1.5. 1/2 times -2, that's going to give me a -1. And then 1/2 times 0, that's just going to give me a 0. My new function will contain the points -3/2, +3, -1, -3, and 0, 1. Let's graph that. Right, so -1.5, +3, -1, -3, and then 0, 1 will be right here. My graph transformed is going to look like that right there. So you can see horizontally we've taken a graph that's doing this and we've smooshed it together a little bit. That was the effect that the 2 had on the graph. All right, let's take a look at y is equal to f of x times 1/2 of x. And this one is actually going to be a horizontal stretch. And the stretch is going to be 1/1/2, which is just going to be 2. So we've got a horizontal stretch times 2. All right, once again, I want to list the points that I have on the graph that was given to me, and then I can actually move it. All right. Oh, we're going to have the same, we got the same graph, so we're going to have the same points. Fantastic. Okay, so we got -3, +3, -2, -3, and 0, 1. All right, let's see what that transformed graph is going to look like. Remember, I'm going to multiply the x values right here times 2. So 2 times -3, -6. 2 times -2, -4. 2 times 0 can be 0. So my transformed graph will have the points -6, +3, -4, -3, and 0, 1. Let's see what happens. All right, -6, -3 is going to be right here. -4, -3 is going to be right here. And then 0, 1 is going to be right here. So the transformed graph is going to look like that right there. So what happened was we took a graph that was doing this and we widened it out some. That's going to be your vertical stretch. It's growing this way. It's growing longer. Example 5. The graph of f of x is given. We're going to graph y is equal to negative f of x. When the negative is out here outside the function, this is a reflection over the x-axis. And so what I'm going to do is I'm going to look at each one of these points and I'm going to plot its mirror reflection down here underneath the x-axis. For example, this point right here is 1 unit above the x-axis. So its reflection should be 1 unit below the x-axis right here. This point is 3 units above the x-axis, so its reflection will be 3 units below the x-axis. And then this point right here is on the x-axis, and so its reflection is the point itself. That means the reflection for this problem looks just like the blue graph right there. When we look at this one, y is equal to f of negative x. When the negative is grouped inside with the x like this is a reflection over the y-axis. And I'm going to do the same kind of thing. My y-axis is right here. I'm going to take each one of these points and I'm going to reflect it to the other side of the y-axis. This point right here is 1 unit away from the y-axis, so its reflection will also be 1 unit away from the y-axis. This point right here is 4 units away from the y-axis, so its reflection should also be 4 units away from the y-axis. And this point, this is 2 boxes away from the y-axis, so its reflection should also be 2 boxes away from the y-axis. And now when we go to connect the dots, our reflection looks just like that. Example 6. Use transformations to graph the function defined by m of x is equal to -3 times the absolute value of x minus 2 minus 4. Okay. Our parent graph for this one, it's going to be the absolute value graph. Okay. All right. And on our absolute value graph, I'm going to leave some room in here because I'm going to do some more stuff to do each one of the translations. All right. We said if we put 0 in for x and took the absolute value of that, it's going to give me 0. And if I put 1 in for x and took the absolute value, that's going to give me 1. And if I put -1 in for x and took the absolute value, that's going to give me a +1. So our parent function, and remember this is my V graph, or it's also called a half line, is going to look like this right here. All right, let's see what kind of transformations we can do on this. According to my chart, I am supposed to do my horizontal translations first. That's this one. This moves everything to the right 2. That means we're going to be adding 2 to our x-coordinate because we're moving the whole graph to the right. We're not going to do anything with the y. This is our y-coordinate right here. But we're moving the x-coordinate to the right 2. That's going to give me the point positive 2, 0, because 2 plus 0 is 2, and I get to keep that 0 right there. All right, 1 plus 2 is going to give me 3, and then I get to keep that 1 right there. And negative 1 plus 2 is going to give me 1, and I get to keep that 1 right there. The next thing I'm supposed to do are my stretches. That's going to be this 3 right here. That's a vertical stretch, so we're going to have to multiply 3 times our y-coordinate. That's these right here. I get to keep my x of 2 right there, and then 3 times 0 is going to give me 0. I get to keep this 3, and then 3 times 1 is going to give me a 3. I get to keep this 1, and then 3 times 1 is going to give me a 3. Alright, so the next thing we want to do then is do our reflections. That's going to be this one right here. This is going to be a reflection over the x-axis. Now, when a point moves to the other side of the x-axis, we get to keep the x, but the sign on y is going to change. Okay, so what I'm going to do is I'm going to multiply negative 1 times the y-coordinates in this column here. So we're going to keep 2, and then negative 1 times 0, well, that's just 0, so we get to keep that one. I'm going to keep that first 3, but negative 1 times that second 3 is going to give me a negative 3. And then I'm going to keep that 1, and negative 1 times that 3 is going to give me a negative 3. But finally, the last thing I want to do is my vertical translation. This is the minus 4. This is going to move everything down 4. And since the y-coordinate is the one that moves us up and down, I'm going to take the y-coordinate and I'm going to subtract 4 from it. Now I'm going to keep my x, so I'm going to keep the 2, and then 0 minus 4 is going to give me a negative 4. And I'm going to keep that positive 3, but negative 3 minus 4 is going to give me a negative 7. And then I'm going to keep that 1, and negative 3 minus negative 4 is also going to give me a negative 7. And right here, these 3 points are the points that are going to be on my translated graph, which is all of this right here. So let's take a look at it. We're going to go positive 2, negative 4 is going to go right here, positive 3, and negative 7 is going to be right here, and positive 1, negative 7 is going to be right here. My translated graph is going to do something like this right here. Example 7. Use transformations to graph the function defined by r of x is equal to the cube root of negative x plus 1. All right, our parent function is actually going to be f of x is equal to the cube root of x. Right, so what we want to do is we're going to make our chart over here for x and then the cube root of x. And then I'm going to leave a little bit of room because we're going to do some other stuff to it. Okay. When I put 0 in for x, and then I cube root 0, I get 0. When I put positive 1 in for x, and then I cube root positive 1, I get positive 1. And when I put negative 1 in for x, and I cube root negative 1, I get negative 1. So the cube root function has a point here, and a point here, and a point here. And this is where the knowledge of what these graphs are supposed to look like, the parent functions, come in handy. Because the cube root function is actually going to do something like this right here. So it's very important that you become very familiar with all of those parent functions that are earlier on in the slideshow. It'll help when you're doing the graphing because we're not allowed to use the graphing calculators when we're doing these. Okay. Now, over here, I can see that I have a horizontal translation. This is going to be 1 to the left, and the left movement is on the x-coordinate. So what I'm going to do is I'm going to take my x-coordinate and I'm going to subtract 1. I'm going to keep my y's. This is my y column right here. All right. So 0 minus 1 is negative 1, and I get to keep that other 0 for my y. Positive 1 minus 1, this is going to be 0, and I get to keep the 1. And then negative 1 minus 1 is going to be negative 2, and I get to keep that negative 1 right there. All right, the only other translation or transformation I have is this right here, the negative. Now, that is grouped with the x underneath the cube root symbol, and so this is going to be a reflection across the y-axis. And when we make a reflection across the y-axis, that means we're going to be changing the sign on the x values, because the signs on the x's over here on this side, they're positives, and when we reflect over to the y, these x's become negatives. So we're going to change the sign on x, and we're going to keep whatever y it is that we have. So let's multiply negative 1 by our x value. Negative 1 times negative 1 is going to give me a positive 1, but I get to keep the 0. Negative 1 times 0 is just 0, and I'm going to keep the 1. And then negative 1 times negative 2 is going to give me a positive 2, and I get to keep the negative 1. And this is going to be the graph of my transformed function. So let's see. Positive 1, 0 is going to be right here. 0, positive 1 is going to be right here. And positive 2, negative 1 is going to be right here. Looks like my graph is going to do something like that right there. And there we have it.